Welcome to Juniper Network's Session Smart SD-WAN Virtual Router Redundancy Protocol VRRP walkthrough. With the release of 5.4 software, your Session Smart Router adds the Virtual Router Redundancy Protocol VRRP as a redundancy configuration option to address the current, often complex and slow implementation for high availability and redundancy. VRRP is an industry standard protocol that addresses the challenge of a single point failure on a network. VRRP is an IP routing redundancy protocol that allows for transparent failover at the first hop IP router by enabling a group of routers to form a single virtual one. So how does this work? First, participating routers generate a virtual router using a unique IP address configured as a gateway. The virtual MAC addresses are assigned randomly, with a range reserved for VRRP as defined in RFC 2378 during the election process. It's important to note that VRRP group number must be the decimal equivalent of the last hexadecimal byte of the virtual MAC address. Second, VRRP is used to elect a router from existing participating routers to play the primary or virtual router role. Session Smart routers in VRRP use a numeric value to assign the primary, where the higher number wins. This router acts as the primary and forwards traffic as the virtual router. Router 2 only takes over when the primary goes down, when those VRRP advertisement packets are not received. The transition is invisible to users connected to the gateway. Let's take a look at a VRRP configuration. Here, you see a client connected to a switch, connected to a router, configured as a gateway. Routers in a VRRP configuration are all in the same broadcast domain and send out their own IP addresses. However, the two router interfaces connected to the switch exchange VRRP advertisement packets with one another. This is represented by the orange line between the primary and secondary routers in this diagram. These advertisement packets are sent to backup routers at regular intervals. Default behavior is 1 second. Here's where the magic happens. When the secondary router doesn't receive those VRRP ad packets, the router with the next highest priority takes over as the primary and begins to forward traffic acting as the virtual router. Furthermore, participating Session Smart routers dynamically assign primary and backup roles based on priority values that you'll configure. We'll see this a little later in the video. For an end user, the normal behavior of ARP requests for the MAC address corresponding to the gateway IP is maintained. Both routers receive that ARP, but only the primary responds, and traffic is sent over to the primary through the switch. Why do I want virtual router redundancy? When your Session Smart routers are configured in dual node or dual router VRRP groups, it enables admins to configure multiple routers as a default gateway, ensuring failovers happen seamlessly and quickly. VRRP is automatic and invisible to an end user. Using the defined priority in your configuration, it ensures the availability of that default gateway through redundant paths. VRRP is an IETF open standard protocol, and finally, when VRRP is paired with our new service route parameter, enable failover, you'll have stateful failovers, where sessions are maintained during a swap. Configuring session resiliency allows the traffic to fail back to the primary service route when the service route is operational again. The max loss, max latency, max jitter settings will determine at what point failover happens. If you're interested in this feature, check out our service route redundancy video. So let's talk about dual node virtual redundancy. There are several benefits for VRRP on Session Smart routers here. The highly available dual node configuration reduces failover time, and when configured with the previously mentioned service route enable failover parameter, your sessions are preserved. As you can see here in the dual node setup, regardless of the interface, the virtual redundancy identifies the best gateway and then forwards the traffic along. Keep in mind that with the enable failover setting, your sessions will swap back to the sunny day gateway when they become available. Now, we're going to explore how to transition your Session Smart dual node deployment to a VRRP setup. To do this, I'm also assuming we'll need to go through the steps to migrate the configuration from the complex, highly available shared MAC setup your Session Smart routers currently use to VRRP. You've already seen my dual node topology, but this time I'll be sending out some simple traffic so you can see the failover in action. Let's take a look. If you're already running a shared MAC config and want to transition to VRRP, it's pretty straightforward. Here you can see my two LAN interfaces in active and standby with that shared MAC address. All we'll need to do here is remove the shared MAC and configure VRRP. After diving down into the LAN interface, we'll select Reset on the shared MAC, and when you do, VRRP settings will pop up beneath it. And all we need to do is give it a virtual router ID, a priority, and an advertisement interval. On our second node, we're going to need to do the same thing. The only difference will be this time we're going to give it a lower priority, making it our standby. So we'll go here, Reset, enable VRRP, router ID, and we'll make this one 99 and commit. And it takes just a moment for this to update here, so I'll give it a refresh. And as we scroll down, we should see VRRP active and VRRP standby. Now, if I move over to device interfaces, you'll see that we no longer have a shared MAC, which means our VRRP is good to go. And if you remember, I mentioned we had some simple UDP traffic running through, so I'm going to shut down a primary node so we can see a failover to that secondary node in real time. The shortest refresh interval is 5 seconds, so it'll say 5 seconds when we measure that failover using the graph. But if you measure it in real time, it's about 2, maybe 3 seconds. So what I'll do is I'll move over here, and I will shut down that node. And shut down. There we go. And as we can see here, the secondary has already become VRRP active. So when we move over to our graph, you'll see that the orange line representing the secondary node has already picked up the traffic, and the blue line has stopped sending around 40 seconds, and the secondary picked it up again around 45. And again, this is because our refresh interval is 5 seconds, but if you measure it, it's around 3 seconds for this failover, and that is dual node VRRP in action.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Networks Certification Program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.